Hi everyone. In this video we're going to finish Chapter 8 by talking about Section 8.5, which has to do with something called bootstrap confidence intervals. Okay? And so this idea is going to be probably really weird for you, and that's okay. But I think it's needed to just give you a sense of what if things go wrong. Okay? So for both confidence intervals that we've looked at before, both p and mu, we had a nice statistical result that gave us the sampling distribution. Okay, whether it's the, well, actually both times it was the central limit theorem, but we didn't really call it that for p. Okay, but both times we had the central limit theorem to help us out. But what if we didn't? What if we didn't? Or even if we had large samples, what if we looked at other parameters that may not be so easy? So instead of the sample mean, the sample median. Okay, there's not a central limit theorem for medians. Okay, that's strictly for means. So when you're in those cases, okay, you may have to quote unquote pull yourself up by the bootstraps without the convenient statistical formulas. So you can guess probably that this is where the name bootstrap came from. Okay. Also, this reference might be really old. Okay, but pulling yourself up by the bootstraps was a common term for like getting yourself on your feet, and like getting out there and doing something when you're knocked down. So anyway, in these cases, you might not have a statistical result to help you, but in fact, there are still ways in which you can come up with confidence intervals without so much theory behind it. Okay, so there's a computation method, okay, or computational method that accomplishes this. Okay, this being creating a confidence interval when you don't have that nice formula called the bootstrap. Okay, called the bootstrap. This method was created in 1979, so actually really recently in the mathematical world, by a statistician at Stanford. His name is Bradley Efron. He still teaches there. He's still alive, and probably still as brilliant as ever. Okay, so Bradley Efron created this. I have the actual paper where he talks about this. I can give you the paper. You probably won't want to read it, but if you do, I'll certainly send it to you. Okay, so that's who created this. The idea behind the bootstrap is a bit odd, okay, but is really simple. So, since you don't have a nice statistical result to build a sampling distribution off of, you kind of have to build that sampling distribution up yourself. Okay, you have to use the data at hand to create what's called a bootstrap distribution. So, there are a few steps to creating a bootstrap distribution. So, one, we're going to sample with replacement of size n from the n observed points. Okay, so not did it again. So you're going to sample with replacement of size n from the n observed points. Again, so that's a weird statement in itself. I have a sample of size n. Okay, so I have n points from some population. And so what I do is essentially I create other samples from my own sample, from my one only sample. I create many samples by sampling with replacement of size n, so of the same size. Meaning that if I have a sample of size 20, what I do is I sample with replacement from that sample until I get 20 numbers. And so the interesting part here is the sampling with replacement. That means I can sample the same number more than once. Okay, so I do that not once, but many times. Okay, so I create many samples. Then I calculate the statistic, whatever I'm looking for, whether it's the sample median, maybe I'm interested in calculating a confidence interval for the population standard deviation, what have you. I calculate that statistic for every sample, and then what I do, which we'll find out in just a second, is I create a sampling distribution or a bootstrap distribution from that. So I have an example here that hopes to illustrate what I mean. So suppose I'm interested in the average time it takes to run a 5K. So I take a sample of size 5. I could count 5 people at a time, so I took a sample of size 5, okay, and I got 5 different times. Okay, so 32 minutes, 29 minutes, 34, 36, and 48 minutes. Okay, so that was my sample of size 5. The first step is to sample with replacement of size 5 from this data. Okay, so bootstrap sample number 1. So I take the first sample with replacement is 34.83. Okay, so I put that there. Next sample is 48.71. Great. Then it was 29.43. Great. And then I went back to 34.83, and I can because that's sampling with replacement. Okay, and then again 29.43. So that's a new sample. So my bootstrap sample 1 looks like that. Notice that there are repeats, and that's okay. So I can do that. I do that not just once. Okay, I can do it twice. Okay, again, so there's 5 more samples. Again and again, all the way down to maybe 100,000 times. I did this 100,000 times. It's really easy to do computationally, okay, with a computer. Very simple, very easy. And so what I get is a sample of size 5 more. Okay, so I have 100,000 of these. And then what I do is I take the mean. If I'm interested in the average time, I can take the mean of those 5 points in each sample. Okay, and so when I do that, I get these bootstrap means, and then I make a histogram of them. This is the bootstrap distribution, or really it's like a sampling distribution of the mean. So I didn't use the central limit theorem, and in fact, if you look at this, it looks not quite normal. Okay, but what I can do with this is create confidence intervals and do all kinds of the inference that I want to with this sort of makeshift sampling distribution. So to create a bootstrap confidence interval, what you would do is take the middle 95% of your means that you got out of the sort of bootstrap process, and those would be your endpoints. So the points such that 95% of the bootstrap means are in the middle, and we know how to do that. The terms that we would use are percentiles, and you would take the 2.5 percentile and the 97.5th percentile, or 97.5 percentile, 97.5. Okay, so for example, with the data that I calculated above, it would say that the confidence interval would be 31.59 to 43.13, and the interpretation of a bootstrap confidence interval is different than one for a regular confidence interval that we've done before. I'm 95% confident that the average time it takes someone to run a 5K is between 31.59 and 43.13. So actually you can interpret it in a similar way, but other people may interpret it in terms of the bootstrap samples. So 95% of the bootstrap samples lie in between these two numbers. Okay, so again, that's not the most important part, but it's something that I think you should know. There are no your turns for this video.